In this video, air-free technique will be demonstrated by the titration of N-butyllithium. When running air-free reactions, we need to do this in glassware that has been oven or flame dried. Collect your vial from the oven using tongs and place it in the desiccator to cool. Be sure to do this quickly and close the desiccator door completely. Once the vial has cooled, we'll weigh out our sample of N-pivyloyl O-toluidine. First, tear the vial, and the N-pivyloyl O-toluidine can be weighed out directly into the vial. Our sample weighs 113 milligrams. It doesn't matter how much N-pivyloyl O-toluidine we weigh out because we'll calculate the millimoles and use that number to calculate the N-BuLi concentration. The first step is to calculate the amount of millimoles of N-pivyloyl O-toluidine that we weighed out. To do this, we divide the 113 milligrams that we read off the analytical balance by the molecular weight, 191.25. We can also set this up using dimensional analysis. And we can see that the milligrams cancel. We've weighed out 0.59 millimoles of N-pivyloyl O-toluidine. Now we're going to estimate the volume of N-butyllithium needed for the titration. This is important so that we don't take up too much into the syringe and have a lot of waste N-butyllithium to get rid of. What we're going to do is assume that the N-butyllithium concentration is close to that on the bottle. The bottle lists a concentration of 2.5 molar, so we'll assume the actual concentration is close to that. Because butyllithium and N-pivyloyl O-toluidine react in a 1-to-1 ratio, the concentration of N-butyllithium times the volume delivered should equal 0.59 millimoles. Solving this expression gives us an estimated 0.3 mils of N-butyllithium that we'll need for the titration. In practice, we'll syringe up a little bit more to correct for the N-butyllithium concentration perhaps decreasing over time. First, I'll fit the vial with the septum and we'll clamp it over here. I'll first demonstrate how to purge by vacuum and backfilling with nitrogen. However, this isn't a good method for this particular titration. You'll see why in just a second.
So before the titration, we thought we should do a quick rundown of how the manifold works. So what it is you saw the N2 tank, the line will come in to this part of the manifold, and it goes all the way through these front lines. Now, there's also a vacuum that goes through the back manifold, and they're connected by this joint right here, and you can actually switch each line from vacuum to nitrogen at will with these little stopcocks. Okay, so since you can switch between them, what it is you can check the two sides. One side has a blue dot and one side doesn't. Blue dot down means vacuum and blue dot up means nitrogen. So that's the bubbler. If you have nitrogen running through the lines, it'll end up running through here, and you can check to see if there's nitrogen flow based on the bubbling of the oil right there that you see.
As Jonathan mentioned, it's easy to switch between nitrogen and vacuum, and this is often a good technique for purging. I can affix a needle to a cut-off 1 milliliter syringe that's attached to the manifold. If I turn the blue dot up, this is flowing nitrogen through, and if I turn the blue dot down, you'll hear the vacuum pump starting to work a little bit harder because it's sucking just air in at this point.
And
I'm just going to turn it to neutral for a second. We can place this needle, pierce the septum in the center, and we can pull vacuum on our vial. Right now, there's a vacuum being pulled inside of this vial. When I switch back to nitrogen, it'll backfill with nitrogen. In this case, that's kind of a problem because our solid kind of bounced everywhere and got on the sides. It's now on this needle, and this wouldn't be good because all of our stuff won't be in the solution for the titration. If we had an oil in our flask, we could purge by evacuating and backfilling as I just showed you, and we would repeat that process 3 times. In this case though, we've demonstrated with this light fluffy solid, this isn't a viable method. For the previous demonstration, note that we were using vacuum, so we were using a thicker walled Tygon tubing. Because I'm not going to use vacuum in the purging method I'm going to show you, I'm going to switch to this more pliable line. This is thinner and easier to manipulate, and once you put it into the reaction, it doesn't move on its own so much. So it's good to use when you're only using nitrogen. With my needle in place, I'll turn the blue dot up to start nitrogen flowing through the needle. I'm going to place a second needle in here, and then we can just wait a few minutes. Nitrogen is flowing in through this tube, and it's pushing the air out of this vent needle. It's a good idea to check your bubbler at this point, and make sure that your nitrogen still is flowing. We can also check that the nitrogen is flowing through our flask by hooking up this needle that's attached to oil in a bubbler. There's just a little pipette that we've placed into the oil, and when we put this in, we should see it bubble. Hopefully at this point, you can envision how we could use the manifold to put our bottle of BuLi under nitrogen as well. However, this is a teaching lab, and we like to be very careful with our important reagents that are very air sensitive. In this case, I don't want to risk that somebody opens another port on the manifold and exposes our good bottle of BuLi to air. So I'm going to put the BuLi under a separate balloon of argon. Note that we have this second tank in the lab that we can use to purge balloons. As with anything, we always purge 3 times. So I'll make sure my tank is on, and I turned on the large valve, and you can see the pressure go up here. Now I'm going to open this smaller valve to fill the balloon. It doesn't take much. You can just fill a little bit while you're purging. Now I'm going to fill up the balloon. And immediately place a black needle on it so all the argon doesn't escape during my travels. Note that the N-butylithium bottle is parafilmed. We'll remove the parafilm. Open the bottle and quickly insert our needle, placing the bottle under argon. Note that this bottle has a SureSeal. It is imperative that you only use the smallest gauge needles in the lab, which are the black needles, when using a SureSeal bottle. Our flask has been purging for an adequate amount of time, so at this point, I'll remove the second needle and throw it into the sharps container that we keep below the hood. Remember to always throw your needles into the sharps container. In the meantime, I've acquired some dry THF in this needle. I had to walk around the lab with it, so I've put the needle into a stopper so that I can safely move about the lab. Note that I acquired the THF from the dry solvent shelf and not the THF in the flammable cabinet. That's not sufficiently dry. I'll take my needle and, using care, pierce my septum. I can now dissolve my solid using the needle to rinse the sides of the flask that might have a little bit of N-pityl O-toluidine stuck to them. I remove my needle and throw the whole thing into the sharps container. I can now lower the reaction and turn on the stirring. I've acquired a needle to get the N-butyl lithium. I'm using a 1 ml syringe, and I'm using a 3-inch black needle. Note that we still need to use black because we're going through the septum, and black is always 22 gauge. I need to purge my needle, however I would never purge it in the good bottle of reagent. That could destroy the sure seal. Therefore I'll use my reaction and draw up a small amount of nitrogen and just let it out into the air. I'll repeat this process 3 times and quickly pierce my bottle of N-butyl lithium. We've approximated that we need about 0.26 mils. So I will draw up about 0.3 mils of N-butyl lithium. We never put reagent back into the reagent bottle, so I'm going to pull back on my plunger to get any residual N-butyl lithium solution out of the tip of my needle. I can push out most of the air and approximate that I do have indeed 0.3 mils. With argon left in the tip of the needle, I'll bring it close to my reaction flask and quickly pierce my septum. At this point, I'm going to take the balloon out of my N-butyl bottle and cap it tightly. I'm just about ready to perform my BuLi titration, and since we're looking for a yellow endpoint, I'm going to place a white sheet of paper below my vial so that I can see the color change easily. I need to get all of the nitrogen out of the end of my needle, so I'm going to draw back again, bend my needle, and slowly twist the barrel of the 1 ml syringe, carefully watching the bubble disappear. In order to get an accurate measurement, I will do this process until a drop of the solution hangs from the needle. See the little drop? It's time to read my syringe. I'm starting with 0.35 mils of solution, 350 microliters. You should perform the titration slowly because there is a chemical reaction going on here. We'll add our solution dropwise, as we should for all solutions. And I am just twisting the barrel of the 1 ml syringe. This is a great trick. If you twist the barrel and push just slightly, it allows you to do dropwise delivery. Can you see the vapors? Note the vapors coming up on the sides of the flask. The reaction is exothermic and the THF is boiling a little bit. I'm going to slow my titration to avoid this. As we near the end of the titration, the yellow color lingers for a longer period of time. I'll slow down to wait for it to disappear. Just thought that was a lot. Once the yellow color persists, your titration is complete, and you should read the volume on the barrel of the 1 ml syringe. The volume is 90 microliters. I have a little bit of BuLi lithium left in my needle, and I need to get rid of this. We keep a sand bath close by and don't have any flammable liquids in range. I can squirt the last bit of my BuLi into the sand bath and discard my needle. Finally, we need to calculate the exact concentration of the N-butyllithium that we titrated so we can use it accurately in our reactions. Using the start and end volumes that we read off of our syringe, we can take the difference and find the total amount of N-butyllithium added during the titration. Given that 0.59 millimoles of N-pivyloyl O-toluidine was weighed out, and that the millimoles of N-pivyloyl O-toluidine are equal to the millimoles of N-butyllithium at the equivalence point, we can divide the millimoles of N-butyllithium by the volume of N-butyllithium delivered, in this case 0.26 mils, and arrive at the concentration of N-butyllithium, which in this case is 2.27 molar.